Um, so I wrote this talk before the morning started, as is proven by the time on the Dropbox. I'm quite pleased to see that quite a few of the phrases that I've used in this talk have already been mentioned by Chris and Stuart as well already this morning, despite us not conferring on it. So it looks like we're kind of all on the same page. So hopefully, what I was trying to do with this is to kind of try and help to frame some of the discussions that we're going to have at the workshop over the next few days. Give a general overview of what we've done so far, particularly what I've been involved in terms of turning clicks in science in Zooniverse projects, with some specific examples and some stuff that's currently going on thrown in there. And yeah, and mostly I'm kind of hoping that this will feed into ideas over the next few days. So Chris spent a lot of the last part of his talk talking about the differences between projects, and I think this is one thing that we really need to identify over the next few days. But actually, rather than differences, we should really be looking for the places where we can find similarities between things that actually, on the face of it, are completely different projects, but wherever there's actually a similarity between data sets where we can actually exploit the same approach, we should obviously try to do that, because these similarities give us hope that we can actually use the same analysis methods and we can actually generalize solutions in code, which is a lot of what Stuart was talking about. So Chris also mentioned kind of trying to work out or classify the differences between different project types. I mean, basically, I started off thinking of like a long list, but really, I think Chris came to the same conclusion that there's only really two different types of task in all of the Galaxy Zoo projects. We ask a question and we get an answer, or we ask someone to scale something or mark something on an image. You can break that down further if you actually think about the subtleties, the subtle differences between, are you actually detecting something or being told there's something there and then you've got to identify it? Have you got to compare two things and tell the difference between them, or match something, or scale, say, a crater or something like that? So there's all these differences. And it's a little bit of an aside, but there's some work being done in Nottingham by a PhD student, James Sprinks, who kind of sits in this strange institute called Horizon, which sits between well, it's in digital economy, so they're basically dealing with how computers are changing lots of things. But he has been working with some experts in human factors and human-computer interaction to try and characterize how these different citizen science projects, different Zooniverse projects, kind of fit within the context of actually a very long history of human factors research. So we didn't really think about any of this, or we weren't even aware of a lot of this literature when we started making these projects, and we're really not even very aware of it now. But ever since particularly the Second World War, there's been an awful lot of focus on trying to understand what people are good at, what computers are good at, and what you do to kind of maximize how people, how to use people in particular jobs. So, for example, people are terrible at jobs that require them to kind of be basically wait a long time, waiting for something to happen, and then say, it just happened. Okay, they get distracted, they get bored. Okay, so tell someone to look at a clock and press a button when the minute hand moves. Okay, they'll be terrible at it. Whereas obviously, that's something that you can get a computer to do terrifically. Okay, so what James has been doing this thing called hierarchical task analysis, which I know very little about, but basically breaking down each different Zooniverse project into the different tasks that are required to try and get an idea of the similarities, the differences, and the different complexities. So this might help feed into to Chris's pub discussion that he mentioned that we should have. So this is the full hierarchical task analysis of a dozen Zooniverse projects. And you can see some are very easy, just one thing here. I'm not sure what project that is, whereas others involve huge, great big trees of different decisions that need to be made. And the idea is, this is work in progress, but is to correlate the differences between these projects against metrics for user engagement, so say the Google Analytics, and data quality metrics as well, so we can try and discover which approaches are working better. James is also working on something that's a bit more direct, so rather than kind of taking all these very disparate projects, which have big differences between them in terms of the science, the way the project is set up, and the tasks involved, by actually just testing whether different ways of constructing a task make differences in terms of the user engagement and the quality of the data. So in this case, what we've done is taken Planet 4 and he's made an extension to Planet 4 for marking craters, so something like MoonZoo, and he's made them it's identical apart from 3 different versions, which give the user different amounts of freedom in what they can do. So there's a fully free version where you basically just say mark a crater, and they've got all the tools available to them right then and there, and they can do whatever they want and then hit submit. There's a version where it's guided, so it says, right, first of all, just are there any craters in this image? If there are, then okay. If you say yes, then it says, right now, just click on where they are. Then once you've done that, it says, right now, size them all. Okay, so it kind of guides you through the process. And then there's a focused version where all you do is say, are there any craters? Are there any craters? Yes, no. Are there any craters? Yes, no, for a while. And then you go, next time you go back, you'll be asked, okay, somebody else marked craters here. Can you tell us what size they are? Can you drop them out? Okay, so you only work on one thing at a time. And so far he's done this in a focused kind of lab-based setting where he's had students who come in for Amazon vouchers to and can be watched doing this, and he's had various collected qualitative comments as well as kind of quantitative results that haven't been analysed yet. And so you get what you probably expect, that people like to have a lot of freedom, but on the other hand, often are a bit unsure about what they're meant to be doing and don't actually do what you actually wanted them to do. Whereas the focused can be very easy, and people feel very approachable, but on the other hand, you might get a bit bored. They kind of feel restrictive, like they're not really doing science; they're just, just hitting yes or no over and over again. So this is all, like I say, work in progress, but and a bit of an aside. And that's all about kind of project design as well, really. And I didn't want to spend too much time talking about project design because a lot of people in the room actually have projects running and data sets already and want to know what the hell to do with those, rather than be told, well, go back and design your project slightly better. So I'll try to avoid doing that too much more. So the projects differ in the ways that the tasks are set up, but they also differ, as again, echoing Chris here, in other ways. So a big issue is the number of classifications per subject, whether we were really confident and just put a huge amount of data in and then got a low response, or whether we didn't have that much data and we got a huge response. That can make a very big difference to what you can do with your data, how many classifications you have per image or whatever you've got in there. The truth set, or the gold standard data, that the phrase that Chris used for it, is also very important, whether it exists or not. So in the case of Supernova Zoo, which everyone will be talking about, they had an amazing truth set because after the fact, they went and got spectra, so they knew if that was a supernova or not. I mean, it doesn't get much better than that in astronomy. In other cases, you've actually just got a whole other set of subjective judgments that just happen to be done by someone who calls himself an expert. So whether that's actually better or not is up for debate. There's also a question about consistency of the data quality. So sometimes all the images will basically be the same quality, whereas for Galaxy Zoo, it was very much the case that the more distant galaxies were a lot harder to tell what was going on in them than the nearby ones. And so this adds a whole extra layer to how you actually deal with the data. And this rather obscure phrase, the existence of invariant quantities, can be useful as well. So it's a bit like having a truth set, but not actually having the whole truth, having kind of a relative truth. And I'll explain how I use this in the Galaxy Zoo data reduction. But despite all these differences, there are usually overlaps, and identifying and exploiting all those little overlaps and the places where we can use the same code to do the same bits of the analysis, I think is one of the things we can really talk about over the next few days. So I thought I'd go through some of the steps involved in dealing with citizen science data as far as I kind of see it. So the first obstacle is actually just getting the data itself. Now, Stuart has already pointed us to the web page for this meeting where he presents all those data sets in a fairly standardized fashion, which is the first time I've ever seen the data presented in such a kind of organized way. Normally, going and getting the data for each project it's kind of got a completely different challenge. It's been going to it fresh each time for each group. I have to have a disclaimer that I'm a bit of a MongoDB noob. Some of you might not even know what MongoDB is, so you're even noobier, but if that's a word. So I come from the old days of 5 years ago where we were using MySQL, don't you know? And so a lot of my data processing stuff that I've written is based on the old, what was called the Juggernaut framework for the Zooniverse. And so it needs a bit of updating to get it working with the new fancy Ouroboros version. So that means, so we've got these different just database setups that we need to deal with, and different ways that the data is stored within those databases. The science team use Ruby. The development team use Ruby. Not a lot of the science teams do, and so there's kind of this difficulty in communication at times, and dealing with the database. The database is optimized, and again, things might have changed a little bit to MongoDB. The database is optimized for being the backend to a web service. That means it's fantastically easy to write to it. It's also fast to maybe have kind of random access to some degree, if you just want that bit of data or that bit of data. But compared to the kind of structures we're used to in doing science data processing, it's very, very slow to just sequentially read through a data set. And when you're processing data, that's normally what you're doing. You have a big data set on disk or in memory. You just go through the whole thing one after another and to do something with it. And databases are astonishingly bad at that. Mongo may have helped change this, but I doubt it's got all the way there. But this should be trivial. It should be that we just have the data access in a standardized form, and it's just done and it's easy. So it sounds like we're getting there. So then there's the actual processing of that data to actually get something out of it. So this consensus engine part that Stuart mentioned. So essentially, I think this can be broken down as two different types of operations. One is just Q&A counts for each subject. So this question was asked, this many people gave that answer, this many people gave that answer, and so on for each subject. And for the marking tasks, some kind of clustering, some consensus catalog for all the markings. So there are some, where am I? Yeah, so I kind of already mentioned some of this. So just give more specifics about data processing performance. So going back to this idea of the database being not necessarily a suitable format, just to give a more concrete example, in Galaxy Zoo, HST, and Moonzoo, what I ended up doing is taking the MySQL, dumping it to a format HDF5, and using Python PyTables, probably banding around lots of words that people aren't familiar with. But I found this gave much more fast and flexible processing. So basically, it was going to take me a year to crunch it in the way that I wanted to crunch it in MySQL. And although I'm a Mongo newbie, I spent a lot of time trying to get MySQL fast. And
does that mean you're doing processing in MySQL? You're actually doing a query to do the analysis, or are you pulling from the table and doing something else?
No, I was trying to do it in SQL. So I tried for a long time to do the right joins and everything to create the table I wanted in MySQL, which was essentially just a row for each object with the counts for each thing. But when you start doing that with the with some kind of weighting as well, so it's iterative, it just becomes a nightmare. Whereas having it on disk in a fast, flexible format was a lot faster. So I couldn't have done it in MySQL as far as I can see, right? As far as I could do. For Moonzoo, so in this case we've been doing clustering. It's taken me quite a bit of time to develop a fast enough method to do custom clustering on the metric on the markings with custom distance metrics, because normally you can assume kind of Euclidean or even a whole different variety of spaces that are kind of coded up for you in quick ways. But if you want to do anything a little bit different, then you end up having to use in Python, the off-the-shelf method went very, very slowly. And so but with effort, I managed to make it 1,000 times faster. Okay, which is quite a speed up. So what I don't want to see is anybody to have to struggle like this again and have to spend that week or two of their lives. Yep.
Were you using the sci-fi clustering? And, maybe not the Skype machine learning clustering?
So I used both, and in the end, I mean, the fastest clustering is by, there's a fast cluster package, but actually the slowest bit was just calculating the distance between everything, because doing that in Python, the routines, you could plug in your own distance metric, but it was done on a pair-by-pair basis instead of actually operating in arrays, so you kind of had to abstract it a bit. So in the end I used Python and things to make it really fast. But that's kind of, you know, we've got these approaches, and I'm sure other people have probably got better ways of doing it as well. We should bring them together so that no one ever has to fight like that again. So we should build on all our experiences. This basic processing, we've kind of done it for different projects now. It should be fast and easy, and I very much appreciate Stuart's point that we should just do the simple thing. We should just be doing by default all the time, straight away. Okay. And all these extra things we want to build in, all these extra sophistications of user weighting or clever algorithms, we should be able to plug them in, ideally, into those standard routines. And Stuart has already thought about this and outlined how he thinks this might work. And in principle, that's it. So if you ask the right questions in the right way, you've got large numbers of equally good answers for every subject, then you're done. Unfortunately, that's rarely the case. So there's a few issues with processing citizen science data that kind of crop up quite a lot. Nonsense, getting best signal, dealing with the fact that you might only have a few clicks for some things, and then a couple of different biases. So nonsense clicks, I mean, we're in a very fortunate position. Most people going to our site are actually meaning to do good. They actually want to help, and it's not very exciting to subvert the system by sitting there for a while misclassifying galaxies. So most of our clicks are sensible, and I think we can just assume that and use that and build on it. But there are cases of rare misunderstandings. So someone just, you know, some people just didn't quite get the point and actually were doing it backwards for a while. There's a lot of trying out and playing in the data sets. There's a lot of people just opened it up and clicked around to see what happened, which is probably a lot of us actually showing people, hey, look, oh, I'll click zebra because it asks you more interesting things if I click zebra, even though it's an antelope or whatever. That's galaxies. So there's actually a lot of that, and it's actually really annoying to deal with in data. Very few kind of malicious participants, but you know, if you can deal with these, then you can probably deal with that. I argue, I don't want to say too much about design, but if you design things correctly, then you can get around a lot of these issues by making sure you really tell people, as nice a way as possible, don't mess around, or you have some extra step where you actually say, are you sure you want to submit this or something? But that adds extra barriers, so yeah, I don't want to be specific. Yeah.
How much automatic is there?
Automatic.
Well, I mean, there are internet robots that click stuff.
I don't know if they actually like
that's not
click
a big
buttons to say.
No.
Do you see that? No. I mean, people. There are ones that follow links, so like spiders that follow links. But I don't know if they actually like click JavaScript buttons.
And also the way we develop the website is very hard. Like one of the problems we have is that it's hard to get people to index because they're relevant. The same reason that would mean it's hard to
So just to give you some ideas of this is a bit of a Moonzoo data set, tiny bit. So you can see this patch here was absolutely the square here with absolutely loads of tiny craters. So this was a little image. This was just one image that was shown. So this is a big area, but this is one image that was shown. That's where someone went around and they just basically marked every little ripple with a crater, even though they were told that the crater had to be above a certain size in the tutorial. They kind of misunderstood and they marked absolutely everything. And you can see these kind of occasionally. And then there's other cases where there's just craters where there's absolutely nothing there, and they're kind of all over the place. But they can be trouble. And the real place where they're trouble is when you have, in general, few clicks. So it looks here like there's absolutely loads of data, but actually, for a given crater, especially when you get smaller, there might only be a couple of markings. And so if you've got some random ones peppered around, that kind of really eliminates a lot of the good markings that you can trust.
How many people look at a moon's image?
So it was done randomly, which is something we don't do anymore. So assets, subjects build up more uniformly typically now. But with this, it's basically a Poisson distribution. So there are, I guess with a mean of about 7 maybe. So there are some
7 reviews of
well, maybe even more actually, maybe even 10 people have looked at each one on average. But that means there's going to be some where hardly anybody's looked, and there's going to be some where more have looked. But there's also quite a threshold to whether people did anything. So even though 10 people looked at an image, only a fraction of those actually marked things, and only a fraction of them took care to mark all the smaller craters. So the incompleteness is terrible, basically.
Is that just a decision to get to the data, or is that?
Yeah, that was kind of just a naive. This is how much I worked out that this many we could put this many images in. And if we got a reasonable response, then each one would be viewed that many times. But what we didn't anticipate in Moonzoo was the extra effort required to actually get people to mark stuff, which we didn't have in Galaxy Zoo, because if you clicked, then you'd made a decision. Whereas in this, you can say next one, next one, next one, without actually giving.
Just on that, you do this in as well, where people are overwhelmed by the number of points they have to mark, so they start with tasks and then never submit because they just completely don't think they're done, so they don't want to do that.
Yeah, I think there's a lot of that kind of thing going on, which is why I think that the design of the task, and it's another reason. So this thing that James is doing, where instead of kind of just confronting you with an image, just saying, are there any craters, or where are the craters, is an easier thing that you could then imagine culling it down, just making sure you only ask people to size one crater at a time, or something like that. Okay. In Galaxy Zoo, I kind of treated nonsense clicks to some degree as being bad users. So I tried to characterize, and I'll show you a little bit more about this in a minute. I tried to characterize or identify bad users, people who were giving us garbage, and downweight them. That's not ideal, and I mean, as Edwin will show, I believe, there's often a time dependency to this. Someone might start off not knowing what they're doing, but then become a brilliant expert the next week. Equally, they might be an expert, but then come home from the pub one night and do some classifications and whatever. And so it's not it's not as simple as that. And if you've only got a few clicks per user, if you're one of these projects where we don't ask you to log in, and Galaxy Zoo, for instance, most of our classifications, or about half our classifications, come from people who only did like less than 10 classifications. You can't really tell a lot about your user in that time. So that's an issue. So I think the opposing point of view to this idea of really getting to know our users and characterize them with sophisticated models is that possibly the simpler point of view is just to treat every click with equal skepticism and basically don't believe one individual unless you've got kind of more to back it up. Yeah.
In Galaxy Zoo, can you indefinitely click on things without being logged in? Or does it at some point say you need to log in? In the later Zoo, you can. That's right. Yeah, you can just click on stuff. It keeps reminding you, but you could just keep going without logging in. With original Galaxy Zoo and Galaxy Zoo 2 and even HST before Candles, you had to log in. But still, we got people who logged in, did a couple, and then went. So even aside from the problem of nonsense clicks, which are arguably not worth anything, some clicks are going to be worth more than others. If you've got somebody who's been doing a task for
for hours on end and really getting used to it, then maybe you want to upweight them. So maybe there's a way we can make best use of data by taking into account or listening to the right users in the right way. I've mentioned low number statistics again, so just to say, it's hard to say anything about it if there's no classifications for a subject, you obviously can't say anything about it, and that seems trivial, but there are plenty of zoos in there which haven't got all the way through their data sets, and so I think we need to be a bit more careful to make sure we don't end up with projects with too few classifications for the subjects that we care about. And again, this is just to show, this is a moon zoo slice. The green circles here are craters marked by an expert. The red are the individual markings, and the blue is a clustering algorithm that's been run on it. So you can see that these craters here, loads of red markings, the blue markings lie pretty well on top of the green, so that's all great. But then there's lots of these smaller craters where there's one lone marking, and in this case, I've used a clustering algorithm that requires an independent verification, so it requires 2 markings for each cluster to be accepted as a real crater. So all of these don't get counted. I could turn it up and say I'm going to accept these. I'm going to accept single markings, but then I'd end up accepting all these nonsense things as well. So it's tricky when you've only got small numbers. There's potentially biases due to the citizen science approach that we're taking. So Chris mentioned this idea of us measuring galaxies, more S galaxies than Z, or Z than S. I don't believe it, so I don't, don't worry. One, that could be a language thing. Another idea that's been postulated for that is just the arrangement of the buttons on the sides. So it was easier to accidentally click one over the other, and so that would, you have to move your mouse further to say it was anti-clockwise than clockwise. Okay, there's lots of subtle things like that could affect you. There's the problem of these misunderstandings, inadequate instructions, and lack of knowledge of your users. So with the going back to Moon Zoo, there's this problem of these small craters, people marking things that are below the size limit. We obviously didn't explain well enough, or it was ignored, or instructions were ignored in those cases. In Galaxy Zoo 2, we see a similar thing. So this is a bit complicated, but if we just focus on this one. So this is the fraction of people who said a galaxy was a merger against the separation of 2 galaxies on the sky. And this little panel up here, which is hard to see, has got a blue line in it and a red line in it, and both of them go up at small separations. So when you've got 2 galaxies close to one another on the sky, people say that's a merger. The difference is that the red line here is galaxies that cannot be physically interacting because they're at different places along the line of sight, whereas the blue line is things that are actually at the same distance from us, so probably are mergers, and they both go up. So here what we're after is people saying that they could actually see evidence that those galaxies were related to one another. What we actually got is just, whenever there happened to be 2 galaxies close together, they called it a merger. They also called it, so this, plus these mergers and irregular and other categories were all lumped together within this odd category, and you could only choose one of them, so we ended up with anti-correlations between the identification of irregular galaxies and merging systems. That was just because of the way that we'd arranged our tree. So there's issues you need to worry about there. So that's kind of our problem because we designed the task. There are also biases that aren't really inherent to the citizen science task itself, that are actually just, anybody doing this in that area of science would have that problem. So the fact that resolution drops off for galaxies as you go to higher redshift isn't really a citizen science problem. That affects all morphological classifications. But unfortunately, it becomes our problem because people haven't been able to see this before, because they hadn't had the statistics to be able to clearly see that it's happening, and so it kind of becomes citizen science a problem. So have I literally got?
You've got like a minute.
Okay, I'm going to take 5. So some solutions are to filter the nonsense. So characterize good and bad participants in ways that are going to be discussed more this afternoon. and I've kind of already mentioned, got ahead of me a little bit, already mentioned kind of ways of using a truth set or some reference to consensus to characterize your good and bad participants. Okay. And we did this in Galaxy Zoo using consistency, so I don't really have time to even describe this simplified version, but basically we say if users are consistent with one another, then we trust them. If they're kind of below some level of consistency with one another, then we actually pretty much eliminate them from the data set from that point on. We downweight them extremely. Another approach, which is fairly new, is to actually want to get rid of the nonsense or get a better signal, is to supplement your citizen science data with some other data set. So use an automated measurement to verify or refine citizen science data. So an example I want to show is being applied to Moon Zoo data by some people at Manchester. And it's a bit of a list, and unfortunately I don't have pretty pictures for it, but essentially what they do is they do this coalescence, this clustering of their markings to get kind of a first set of craters, lunar craters, but then they use that information to create template images of what a crater looks like, and it's not quite as simple as that because they use derivative images and things like that. And then they go to everywhere where a citizen scientist said there was possibly a crater, and they do that template, they match that template, and they get an objective statistic of how likely it is that there actually is a crater there. Okay, and so that gives you a refined crater size, so you're not just having to take the size the citizen scientist gave you, and it gives you this quality statistic. And then they can actually go an extra level, and they use expert markings to construct the expected histograms for markings of true and false craters, and then use a model to correct for that. I'm getting pushed off. But
I know, because we have to get out of the room.
Okay.
Another talk is in here.
Okay. So various more solutions. We can get more clicks, or consider changing your project if you've got low numbers. If you've got biases, there's lots of calibrations you can do. It's worked well for Galaxy Zoo, and you can see it in the paper. There's lots of experience in this room on doing all of this, and it's a great opportunity to bring it all together, as we've already heard. I'd argue that we really need to get the analysis working quickly, like Stuart said, so that we can quickly adapt when we see that we're getting data that isn't appropriate. We can actually change the project, so we need to be able to do this processing on the fly. And but we shouldn't forget that what we're doing is awesome, even if it's sometimes a bit tricky. Yeah. Sorry for going on.
So with that, if you have questions for Stuart, you can ask him outside.